Here is an explanation for the answer to final exam, question number 94 in Alternative Energy Demystified, 2nd edition. If you have the printed book, please see page 331. When talking about the operation of a heat pump, engineers sometimes refer to the ratio of the thermal energy actually transferred to the input energy that the system needs to do the job. The technical term for this specification is what? Is it heat entropy? Is it thermal efficiency? Is it coefficient of performance? Heat of vaporization? Or coefficient of mobilization? Well, the correct choice here is choice C. It is called the coefficient of performance. Now, sometimes you're going to hear the term efficiency with regards to a heat pump, but we have to be very careful when we talk about that particular concept, because a heat pump does exactly what the term says it does. It moves thermal energy from one place to another. It doesn't actually generate any thermal energy, like, for example, a space heater, an electric space heater, converts electricity into thermal energy by simply dissipating the electricity. And then there are other types of ways of heating your house, like, for example, burning fossil fuels, such as oil or propane or natural gas. But a heat pump simply moves thermal energy from one place to another. So let's look at an example of a heat pump here that is intended to warm the interior of a house. The interior of the house is over here on the right. Here's the exterior wall. This is the outdoors over to the left of the exterior wall. Heat energy from the outside is transferred to the inside by means of this particular scheme, which happens to be figure 3-5 in the book. So if you want to go to page 56 and look at figure 3-5 and read the explanation there as to how all of this works. Now, the interesting thing about that is that sometimes the heat energy that's moved from the outside to the inside, more or less like this, although it doesn't actually follow this path, that's the general direction in which the heat energy is transferred from the outside to the inside. All of this apparatus is designed to, it's like an air conditioner more or less operating in reverse. You know how an air conditioner will cause hot air to go outside, and that air, it might be 96 degrees Fahrenheit outside, and you can cool your house down to, say, 82 degrees Fahrenheit inside, and you go outside and you feel the air coming out of that thing, and it's hotter than 96 degrees. It's like an oven. It's so hot. Almost like an oven, it feels like. Well, what's actually happening, even if this temperature here to the left of the exterior wall is a good deal colder than the temperature inside your house, it can still take heat energy from the outdoors and move it inside, because there's always heat energy in the environment, unless it's absolute zero, minus 459 and a fraction degrees Fahrenheit, or minus 273.15 degrees Celsius, roughly. Unless it's that cold outside, there's always some heat energy out here. And a heat pump, if it's not too cold, as long as it's relatively above about 4 degrees Celsius, you can get good efficiency from one of these and good coefficient of performance. And the interesting thing is that the coefficient of performance may exceed 100%. That is to say, you can move more heat energy from the outside to the inside than it actually takes to do it. So you might, sometimes you'll hear of a coefficient of performance of 150%. When they say that's the efficiency of a heat pump, though, that's not true. You can never have more than 100% efficiency in anything. That would be like a perpetual motion machine, and you can't have anything like that. But it's called the coefficient of performance, or COP sometimes, and the correct choice once again is C.